Today we are learning 1-4, which is about angle measures. This is from the McGraw-Hill Geometry textbook. So before we begin this section, one of the most important things is to understand the vocabulary terms. So we're going to start off by defining these words, which will make all the exercise a little bit easier. So what is a ray? A ray has an endpoint, but extends in the opposite direction. So if we were to draw it, a ray has an endpoint, and it extends in the opposite direction. So in words, it has an endpoint. Okay. Okay, it has an endpoint but extends in the opposite direction. The next word is probably one of our most important words. It's called an angle. An angle is basically two rays put together. So it has to have an endpoint. Okay. That's an angle. It's two rays put together. They have a common endpoint. Two rays with a common endpoint. That picture right there is an example of an angle. We have to name an angle with 3 points, okay? And we'll talk about how to name the angle right now. But that common one is the most important, where they meet up, okay? So I have ray AB, I have ray AC, and they meet together at point A. The next word we're going to define is vertex. It's the common endpoint where they meet. The next 3 words are words that you've done before. We have right angle, we have acute angle, and we have obtuse angle. Right angle means that angle is equal to 90 degrees. Acute angle, acute is going to be less than 90. And obtuse is going to be greater than 90. Okay, so if we have an 89-degree angle, that is considered an acute angle. We can't go, there are some angles where we can go based off of looks by saying, yes, it's acute, because you can tell it's a small angle. But when you get an angle that's close to 90, you can't just call it a right angle unless it has a little box that tells you that it's actually perpendicular, that tells you it's a right angle, okay? So how can we name an angle? How are we going to name an angle today? We're going to name an angle with 3 capital letters. This is one of the ways. Now, to me, that's the most important one, okay? So when I say 3 capital letters, we're going to name it based on, we're going to go off the side, the vertex, and then the side. So if we look at that picture that we had on the side, if we were to name that one, we'd go BAC. So it's not alphabetical. You need your vertex to be in the middle. So most important, vertex in the middle. So for that picture, we would call it BAC. We can name that one angle BAC, or we can name it CAB. The only thing that has to stay the same 100% is your vertex has to be in the middle. So that A had to stay in the middle. The other way you can name one, and we won't do it as often, but we will do it, you can use one capital letter if it doesn't have anything else attached to it. So if we have an angle that looks like this, and it has an F right here, and there's no side points, we can call that angle F. So if it doesn't have other points, you can call it by the vertex, or we can use 3 letters. So that can be angle F, or we can call it E, F, G. So now we're going to go to this image, and we're actually going to start naming some. Okay. So we have this image right there. It's a quadrilateral, but I'm going to look at how I'm going to name these. So it wants me to look at the vertex with angle 4. So angle 4 is right here. If I were to name an angle, that has to be in the center, that letter. So what letter is touching that one? B. Now I can't just call it angle B because angle B is part of 2 different angles. So I have to use 3 letters to name it. So if I want to name A, B, D, it does matter because A, B, C would be 4 and 3. I don't want 4 and 3, I just want 4. So A, B, D. The only other way to name that one would be D, B, A. Now it says name the sides of B, D, C. Well, those letters are the only ones I want to use then. So if it tells me that I'm using B, D, C, then these 3 letters are the sides. So I have sides BD and I have sides CD. Again, it doesn't matter if they're out of order. So if we were to highlight BDC, follow them in order, B, D, C. Well, what are the 2 sides? I have side BD and I have side CD. And what is another name for DBC? So I'm going to use another color. And I know you guys don't have highlighters in front of you. You can mark with your pen, but at least visually you'll see. So D, B, C, I can call it by this number right there. So I can call that angle 3. I can also call it angle CBD. Okay. So those are certain ways we're going to name them today. Now the next one we're going to go based off of looks and based off of symbols. So it says to classify each angle as right, acute, or obtuse. Again, if we're going to call it right, it has to have the little box that tell me it's right. And now the acute ones and obtuse ones are going to be kind of obvious. So for the first one, MPR. MPR is this big angle. Obtuse, perfect. Okay. What about NPS? Perfect. What about RPN? And SPR? So now we're going to go to the back. First, we're going to start off by defining congruent angles and angle bisector. So what is a congruent angle? Well, congruent angles are 2 angles that are equal to each other. And I'm going to start using symbols. 2 angles, congruent to each other. If it tells you they're congruent, that means they are equal to each other. Okay. So now that we start using symbols, we have the angle symbol and we have the congruent symbol. Next one is angle bisector. If you have an angle bisector and it tells you that something is bisecting the angle, that means it's cutting it in half. So it's cutting into 2 pieces that are equal to each other. So angle bisector, it cuts So now we're getting to some practice problems here. QP and QR are opposite rays, and QS bisects PQT. So I'm going to go to this image, and I'm going to actually mark what it told me. It said that QS bisects. Actually, let me just do it here. Okay, so here's this image. It kind of got shifted down. QS is my bisector. So this right here bisected PQT. So it bisected this angle. Okay, so I know that QS, it's going to cut those two pieces and they're going to be equal to each other. So number 1 says, if the measure of angle PQT is equal to 60 and PQS is equal to 4x plus 14, find the value of x. Okay? So I have these two angles. And it says PQT is equal to 60. So that whole thing right here is equal to 60. That means that each piece is equal to 30. So it told us that PQS. So is PQS the whole thing, or was it half of the 60? So PQS is half. So I'm going to set it equal to 30. Okay? So I'm going to go back in and solve. (4x plus 14) is equal to 30. And for those who didn't know where the 30 was, because it was an angle bisector, we did 60 divided by 2 equals 30. Okay? And now we just use our algebra skills to solve it. Subtract 14 on both sides. Divide by 4. And the question was solve for x, and we have now solved for x. So question number 2 is now talking about PQS and SQT. So we go to PQS, we go to SQT. Because SQ was an angle bisector, those two angles are equal to each other. So we come here and say that the two angles are equal to each other. So if you want some work on there, angle PQS is equal to angle SQT. So PQS, 3x plus 13 equals 6x minus 2. Go ahead, take some time, try to solve it on your own. Pause it if you have to, and then come back and see if you have the right answer. So now I've solved for x. You should have gotten 5, but here's the problem with that. If I tell you the answer is 5, I'm wrong. Because this question is not telling me just to solve for x. It's actually telling me to solve PQT. Now we're using that same image, but on the first question it was 60. That same image on the second question, it wasn't 60 anymore. So it's different values for it. So I know. Now we have to plug it back in. So we've solved for x, but it wants PQT. So when we look at this image, PQT is the whole thing. So again, I'm using the same image with different numbers. You'll find that in geometry, you'll use the same image sometimes 4 times. The rules are still the same, just the numbers are different. So it's still an angle bisector, which is why we don't go based off of looks. The first time, each of those was 30. This time, they're not each equal to 30, okay? But that's still a bisector. So PQT is both of them. So when I plug it back in, I have a couple options. I can plug it into both of them, add together. Or I can plug it into 1, multiply by 2 because it was a bisector. So it does not matter which one you choose. I'm going to go ahead and add them together. So I have 3x plus 13 plus 6x minus 2. And now I'm going to plug the 5 into my x's. My final answer is 56 degrees. So for the next question, we're using this image right here. So on the directions, it says that BA and BC are opposite rays. That means it forms a straight line, and that means we know it should equal to 180 degrees. It also tells us that BF bisects CBE. So if this bisects, that means it cuts it in half. So the two pieces are going to be equal to each other. So angle 3 is equal to angle 4. So for every one of these questions, no matter what, angle 3 is equal to angle 4. I can't make any assumptions about anything else. The angles are equal to each other. And if I add up all 4 angles, because they're opposite rays, I need to get 180 degrees. So those are the only rules that are going to apply for every single question, okay? So the first question says EBF, okay, I see EBF, that's also angle 3. EBF is 6x plus 4. CBF is 7x minus 2. But it wants us to find EBF. Well, EBF is equal to CBF, okay? So I'm going to take those numbers, and I'm going to come and set them equal to each other. So angle EBF is equal to angle CBF. I'm going to plug them in there, solve for x, but the final answer doesn't want just x. It wants me to plug x back in, okay? So 6x plus 4 equals 7x minus 2. You have choices here. You can move your x's over first. You can move your numbers over first. If you're really good at math, then move them both over at the same time. But I'll go ahead and show what I'm going to do on it. I'm going to subtract 6x on both sides. Then I'm going to add 2. I know that x is equal to 6. Now we're going to plug in that value back into EBF. So EBF was 6x minus 4. Six times 6 minus 4. Oops, plus 4. Thank you. And it is 40. So the next question says, if the measure of angle 3, so I'm going back to that same image. If the measure of angle 3 equals 4x plus 10, and the measure of angle 4 equals 5x, find angle 4. So once again, I'm talking about the angle that was bisected. So the two pieces are equal to each other. So now we go back to the question. So angle 3 is equal to angle 4. Okay? So I'm going to plug in those numbers. 4x plus 10 equals 5x. And I want to solve for x. I'm going to subtract 4x on both sides. I've already solved for x. It's 10. But it's asking me for the measure of angle 4. Well, the measure of angle 4 is 5x. So 5 times 10, the measure of angle 4 equals 50. We're going to skip to question 6 this time. Question 6 says, hey, angle 1 is now equal to angle 2. So I'm going to put the double lines so that those two pieces are equal to each other. And it says ABE is equal to 100. So if that whole thing, A to B to E, If this whole thing equals 100, how much does each piece equal to? 50. Good job. Okay.
Wow.
It says that ABD is equal to 2 times R plus 5. But the final answer that wants DBE. So either way, it wants us to know we got to solve for the R and we plug it back in. Okay. So we know it's 50. Okay, so question number 6. We know that angle ABD is equal to 50. Because we cut that 100 in half. We divided it by 2. And it told us this time that ABD was equal to 2 times R plus 5. So we need to solve for R. When I have a number outside my parentheses, I distribute to everything inside my parentheses. So here and here, I have 2R plus 10 equals 50. Minus 10, 2R equals 40. Divide by 2, R equals 20. And since the question says find R and DBE, well, I found R, there's one of my answers. Well, and DBE, there's no work for it. I had a 100-degree angle that was bisected. How much did the half equal to? So angle DBE is equal to 50. So that's going to be all for 1-4. If you like these videos, subscribe to this channel. We'll have some awesome geometry videos going on. Have a great day.